A covalent bond is a chemical bond that involves the sharing of electron pairs between atoms. The stable balance of attractive and repulsive forces between atoms when they share electrons is known as covalent bonding. For many molecules, the sharing of electrons allows each atom to attain the equivalent of a full outer shell, corresponding to a stable electronic configuration. Covalent bonding includes many kinds of interactions, including I-fluorine bonding, I-euro bonding, metal-to-metal bonding, agostic interactions, and three-centered two-electron bonds. The term covalent bond dates from 1939. The prefix co means jointly, associated in action, partnered to a lesser degree, etc. Thus a covalent bond, in essence, means that the atoms share valence, such as is discussed in valence bond theory. In the molecule H2, the hydrogen atoms share the two electrons via covalent bonding. Covalency is greatest between atoms of similar electronegativities. Thus, covalent bonding does not necessarily require that the two atoms be of the same elements, only that they be of comparable electronegativity. Covalent bonding that entails sharing of electrons over more than two atoms is said to be delocalized. History. The term covalence in regard to bonding was first used in 1919 by Irving Langmuir in a Journal of the American Chemical Society article entitled The Arrangement of Electrons in Atoms and Molecules. Langmuir wrote that we shall denote by the term covalence the number of pairs of electrons that a given atom shares with its neighbors. The idea of covalent bonding can be traced several years before 1919 to Gilbert N. Lewis, who in 1916 described the sharing of electron pairs between atoms. He introduced the Lewis notation or electron dot notation or Lewis dot structure, in which valence electrons are represented as dots around the atomic symbols. Pairs of electrons located between atoms represent covalent bonds. Multiple pairs represent multiple bonds, such as double bonds and triple bonds. An alternative form of representation, not shown here, has bond-forming electron pairs represented as solid lines. Lewis proposed that an atom forms enough covalent bonds to form a full outer electron shell. In the methane diagram shown here, the carbon atom has a valence of 4 and is, therefore, surrounded by 8 electrons, 4 from the carbon itself and 4 from the hydrogens bonded to it. Each hydrogen has a valence of 1 and is surrounded by 2 electrons, its own 1 electron plus 1 from the carbon. The numbers of electrons correspond to full shells in the quantum theory of the atom. The outer shell of a carbon atom is the n equals 2 shell, which can hold 8 electrons, whereas the outer shell of a hydrogen atom is the n equals 1 shell, which can hold only 2. While the idea of shared electron pairs provides an effective qualitative picture of covalent bonding, quantum mechanics is needed to understand the nature of these bonds and predict the structures and properties of simple molecules. Walter Heitler and Fritz London are credited with the first successful quantum mechanical explanation of a chemical bond in 1927. Their work was based on the valence bond model, which assumes that a chemical bond is formed when there is good overlap between the atomic orbitals of participating atoms. These atomic orbitals are known to have specific angular relationships between each other, and thus the valence bond model can successfully predict the bond angles observed in simple molecules. Physical properties of covalent compounds, polarity of covalent bonds. Covalent bonds are affected by the electronegativity of the connected atoms. Two atoms with equal electronegativity will make nonpolar covalent bonds such as Ha-H. An unequal relationship creates a polar covalent bond such as with HCl. Subdivision of covalent bonds. There are 3 types of covalent substances: individual molecules, molecular structures, and macromolecular structures. Individual molecules have strong bonds that hold the atoms together, but there are negligible forces of attraction between molecules. Such covalent substances are usually gases, for example, HCl. SO2, CO2, and CH4. In molecular structures, there are weak forces of attraction. Such covalent substances are low boiling temperature liquids, and low melting temperature solids. Macromolecular structures have large numbers of atoms linked in chains or sheets, or in three-dimensional structures. These substances have high melting and boiling points, are frequently brittle, and tend to have high electrical resistivity. Elements that have high electronegativity, and the ability to form 3 or 4 electron pair bonds, often form such large macromolecular structures. See also. References. Sources: Covalent Bond Euro Single Bonds Shim Guide. 2000. Retrieved February 5, 2012. Electron Sharing and Covalent Bonds. Department of Chemistry, University of Oxford. Retrieved February 5, 2012. Chemical Bonds. Department of Physics and Astronomy, Georgia State University. Retrieved February 5, 2012. External links: Covalent Bonds and Molecular Structure, Structure and Bonding in Chemisya Covalent Bonds.